So this here was some contributed code to my simulation of the universe, and I'm going to run them both. There's some code differences, and this one is a bit faster, and it also runs in 88 lines of code versus 143. It was made by GoToLoop, and let me just run them both. He made a very nice contribution. So this one's running a bit faster. It doesn't look like that right now because there's more pixels on this one right here than there is over here. But overall, this one has better performance, so it's a very nice contribution. I'll have a link to the forum post in the description. This one over here is mine. There's nowhere near as many pixels right now. That's why performance is different. But this one overall runs faster with the same number of pixels. And you can see they're both 150 cubed. And so they're both 150 cubed, but he had a bit of a different way of rendering the graphics, which makes it a difference in performance. And in a second, I'll go ahead and share that. It paused when you clicked away. However, you can resume it over here. He made a pause and resume system, which is pretty neat. So I'm gonna go ahead and show the code right here. Once these start to finish off and die off in the particle count. Alrighty, I'll show the code. So let's start from the very top. If we look, there's a bit different way. He still has the 4 dimensions. However, the number of particles is at the end versus the beginning. Which that's not a major difference yet, but he made a memory mapped for the colors, which is pretty cool. And he ran his in web browser, which was pretty neat. So let's go down to setup. So size, he used P3D versus OpenGL. I did change the dimensions of the window just so that I would be able to share it easier. But alright, so frame rate, he allows it to have the frame rate changed. So he's running at 60 frames, just like me, so no difference there. But init universe, let's initialize universe, let's see. So shuffling through every particle, so he used something that would be more efficient for the opcode. Let's look at matters, what matters is. Alrighty. So matters, let's look, oh, here's matters, it's the whole array. So shuffling through all of matters using, alrighty, so he initialized the array here, and chance is the possibility of a particle being placed there. So if we go up, we can see chance is 1000. If we scroll down in my code, we can see, let's look, try universe, let's find init. Okay, 1000, so that's the same. It must have looked slower because I accidentally paused it. I didn't realize there was a pause button until midway through. Okay, so let's go down to render universe. So he has the camera. His camera was a bit neater than mine was. Mine was a bit messy. Render universe. So render draw universe same, but let's see how he renders his. So he loads into a new boolean mi matters of I with I to shuffle through, and then boolean two-dimensional mj. So alright, so this part here would be the third dimension. Yeah, he's got a bit more boolean logic going on, but this is here performing chemical reactions between the two particles and their own universes, and this is setting the x and y position to draw the matter at, and this is the alert to make sure that it's not outside the universe, because, you know, drawing things outside of the universe would not be good, because then it wouldn't be bound to work, because it would be operating with a portion of the matrice outside of it. So if we look at here, alrighty, so he's changing where the matter is located. Let's go to here, draw matter. So let's go down to draw matter. So the x, y, and z. So then x, y, and z are variables, and then the random is moving the particles, same way of moving that I had over here, just a bit neater. And alrighty, x, y, z equals x or y or z, color equals 0. Alrighty, so those are things there. Let's see. C matter. X, Y, Z inks. Alrighty. So the color is the final argument. Alrighty. So I'll have a link to the forum post in the description. You can go ahead and check out his code if you want to run it for yourself. Thank you for sharing this go-to loop. 1 second. Let me end the video. And thanks for watching. Be sure to subscribe if you haven't already. Check out my original video.